Now we will discuss verification of Ohm's law. What is Ohm's law? At constant temperature, V is directly proportional to I. That is, the potential difference applied across the ends of a conductor is directly proportional to the amount of current flowing through it. When we remove the sign of proportional, then we get R, that is the resistance, and from here we get the R as the ratio of potential difference and the amount of current. That means if we want to verify Ohm's law, then we must have to prove that every V is to I ratio is a R and R is a constant. Basically बच्चों, अगर हम Ohm's law verify करना चाहते हैं तो हम क्या करते हैं? हर एक चेंजिंग V और I की वैल्यू एक रेजिस्टेंस के लिए क्या आनी चाहिए? हर बार कांस्टेंट। मतलब अगर एक रेजिस्टेंस फिक्स है, अगर रेजिस्टेंस Ohm's law को फॉलो कर रहा है, तो उसमें अगर V और I की वैल्यू चेंज हो रही है तो वो इस अकॉर्डिंग चेंज हो कि उन दोनों का रेशियो हर बार क्या आए? एक कांस्टेंट आए, and that constant is R. So on that basis we try to verify this Ohm's law by a setup, by an experiment. For this we take a wire, a nichrome wire, or you can say a resistor wire, around which we connect a voltmeter. Voltmeter is always connected in series. Why is it so? Because voltmeter has infinite resistance. Then an ammeter is always connected in, voltmeter is connected in parallel because the resistance of voltmeter is infinite. And ammeter is connected in series. Beg your pardon? Ammeter is connected in series because it has infinitely small resistance. Then a battery or source, a switch or key you can say, and then a rheostat. Rheostat means a variable resistance. So both this resistance and rheostat are connected in series combination with each other. Now we connect this key. When we connect this key, then the circuit will be complete and the current will start to flow from this circuit. This both combined resistance as a combination in the series will withdraw the current from it. In the first case the current will be I1 and the potential difference across R is V1. Then we'll change the rheostat value. How? Rheostat has a knob. If we rotate the knob, then the value of rheostat, value of the resistance of the rheostat varies. So by displacing the knob we change the value of rheostat. अगर हम बच्चे rheostat की वैल्यू चेंज करेंगे तो टोटल रेजिस्टेंस की वैल्यू चेंज हो जाएगी, तो यहां से जो करंट विड्रॉ होगा उसकी वैल्यू चेंज हो जाएगी. The second time we get the value V2 and I2. जब बच्चे मैं यहां से इसकी वैल्यू चेंज करूंगा तो इसके अक्रॉस जो पोटेंशियल डिफरेंस होगा उसकी वैल्यू भी चेंज होगी और जो इसमें से करंट पास होगा उसकी वैल्यू भी चेंज होगी. I get the value V2 and I2. Similarly, when I rotate the knob one more time, when we change the value of rheostat one more time, we get another value, that is V3 and I3. Then find the ratio. V1 by I1, V2 by I2 and V3 by I3. We get R1, R2 and R3. If we observe that R1, R2 and R3 are equal, that means the value of R in each case is constant. अगर हर बार वैल्यू या बच्चे R1, R2 और R3 की हर बार अप्रोक्सीमेटली कांस्टेंट आ रही है, इसका मतलब हर बार V और I का रेशियो क्या है? फिक्स है, कांस्टेंट है. एंड V और I का रेशियो कांस्टेंट कब होता है? Ohm's law के केस में. So this experiment will prove that Ohm's law will be followed or not. That is, V is to I ratio is a constant and that constant is known as R. That is resistance. If we draw a graph on Ohm's law, then that graph will be a straight line. The graph of Ohm's law is a straight line. And if there is no straight line, that means that is a known ohmic resistance. That means it does not follow Ohm's law. Next thing, bache, the slope of this VI graph tells us resistance. If you find the slope of this VI graph, then you will be able to find the resistance of the conductor. So that's how you will verify the Ohm's law.